The study investigates the necessity for more detailed representations of sound sources in urban noise maps, focusing on three key uses: noise-related complaints, soundscape quality assessment, and guidance for urban planners. It emphasizes the importance of adapting visualizations to the target audience and ensuring data accessibility. Urban noise monitoring and visualization platforms have been developed to provide insights into urban soundscapes, but they often lack in-depth perceptual insights and comprehensive analysis of the impact of various sound sources. Noise maps and measurement campaigns have been employed to understand urban noise, but they do not provide a nuanced understanding of the perception of noise. Recent research has shown the importance of visualizing the presence of multiple sound sources in urban environments, which introduces complexity to the visualizations. This paper aims to investigate whether incorporating multiple sound sources information can enhance the analysis of city stakeholders currently using noise visualizations. It also seeks to understand which stakeholders utilize noise visualizations and to what extent the existing visual representations meet their needs. To achieve this, qualitative interviews were conducted with a diverse panel of stakeholders, including nonprofit environmental organizations, city technical services, officials, and non-specialists. The interviews, which are detailed in Section 2, provide valuable insights into the perspectives and practices of these stakeholders. The results indicate that incorporating multiple sound sources information can significantly enhance the analysis of city stakeholders currently using noise visualizations. Furthermore, the study highlights the importance of visualizing the presence of multiple sound sources in urban environments and the need for more nuanced understanding of the perception of noise. The research involves a diverse group of stakeholders, including association directors, technicians, and project managers who provide expertise in data processing, sensor work, source recognition algorithms, and ecological transition. Technical services, city officials, urbanists, project owners' assistants, acousticians, and geomaticians contribute to the comprehensive nature of the study. Non-specialist participants such as front-end developers and orthophonists also play a crucial role. The structure of interviews is detailed, highlighting various parts involved, which is essential for understanding the methodology and scope of the research. To gather insights from stakeholders in noise management, a 10-minute interview was conducted to collect information on their professional experience, responsibilities, and current practices. This included their interactions with other stakeholders, duration of professional experience, and potential use of source recognition tools. Following the interview, a 5-minute demonstration of 2 noise visualization platforms developed by Pierre was presented. The first platform, a noise map, provides a visual representation of noise levels in a given area, as shown in Figure 1. The second platform, UMRAE, is a comprehensive noise monitoring platform that aggregates data from multiple sensor networks, enabling users to select sites, consult noise indicators, compare different periods or sites, and visualize and playback sound events. UMRAE features the harmonica index, a graphical representation that highlights the impact of 2 major components on the sound environment: the ambient background noise level and the level of sound events emerging from this background noise, as depicted in Figure 3. After the demonstration, participants were asked about their current utilization of noise maps or platforms like UMRAE in their professional activities and their willingness to consider employing such tools in the future. This information gathering process aimed to understand stakeholders' familiarity with noise visualization tools and their potential interest in adopting these tools in their work. The section discusses the strengths and weaknesses of existing noise mapping and observation platforms. Participants were asked about their insights on these platforms, considering each visualization independently. They also provided perspectives on potential user groups for these visualizations. The discussion turned to visualizing multiple sound sources, such as traffic, voices, and birds, and participants were asked if they find it beneficial to visualize these sources on noise mapping or observation platforms. They were also asked to elaborate on how they would envision this representation. Lasso, a novel web-based platform, provides access to spatio-temporal datasets related to soundscapes. This platform features a 0 to 10 scale, illustrating the presence of traffic, voices, and birds over time. Additionally, it presents graphs showcasing the eventfulness and pleasantness of sounds, as well as 2 types of maps: point-based measurement maps and interpolated data maps. To gather user feedback, in-depth interviews were conducted with participants, who were encouraged to share their opinions on the suitability of the 3 identified sound sources: traffic, voices, and birds, and suggest potential refinements or additional categories. Participants were also asked to identify other stakeholders who might be interested in similar visualizations of sound sources. The interviews revealed that users valued the platform's ability to visualize and compare soundscapes, but suggested the need for more nuanced categorizations, such as distinguishing between different types of traffic or bird species. The study's findings highlight the importance of engaging with stakeholders to ensure that sound visualization platforms meet their needs and expectations. Furthermore, the results underscore the potential of LASSO as a valuable tool for urban planners, researchers, and policymakers seeking to understand and mitigate the impact of soundscapes on urban environments. The research paper explores 2 distinct use cases for sound representation platforms, addressing noise-related complaints and soundscape exploration. For noise-related complaints, detailed data collection at precise time intervals and locations is crucial. Visualizations should display multiple sound sources to identify the most problematic source and include precise noise indicators like the harmonica index for easier understanding. In soundscape exploration, the goal is to provide a broader representation of the soundscape at the city scale, benefiting the general population, real estate agents, and educators. Source recognition is key in both use cases, aiding in identifying and understanding sound sources and their contributions to noise levels. This information can effectively address noise-related complaints and provide a comprehensive view of urban soundscapes. A soundscape consultation platform must cater to the diverse needs of urban planners and general users. To achieve this, several key requirements and suggestions are proposed. Firstly, data representation is crucial. Urban planners require precise, localized noise level data for specific neighborhoods or streets, which can be effectively conveyed through detailed maps. In contrast, general users benefit from interpolated maps with visual clarity, where solutions like marking measurement points or presenting noise data over substantial areas can address precision concerns. Indicators must be accessible and meaningful to the general public. The graph of pleasantness and eventfulness, as showcased on LASSO, bridges the gap between sound maps and citizens' perceptions. Additionally, the option to listen to audio from areas of interest enriches the user experience. To avoid overwhelming users, the platform should incrementally increase in complexity, introducing more complex visualizations or indices only as needed. This approach ensures users can engage with information at their own pace, based on their level of familiarity and expertise. The integration of various data domains, including air and soil pollution, and topology, is essential for urban planners. However, presenting both noise map and observation-based sound platforms may lead to overwhelming presentations. A balanced integration of both representations' functionalities is therefore desired. The approach to sound representation is context-dependent, varying based on project dependencies. Localized information is paramount for urban planners, as noise levels can vary greatly between streets and plots. This level of detail is critical when dealing with programs or operations at the street scale. While urban planners may value representations like noise map and observation-based sound platforms, they may not necessarily use them directly in their reports in their current form. Urban planners require direct access to raw data to create personalized representations tailored to each project's context. They prioritize precise measurements of noise levels for decision-making and prefer on-the-spot information through questionnaires from inhabitants. Noise indices like LAEQ, lane, and LDEN present accessibility challenges for non-acousticians. To address this, promoting public education on existing sound indicators and introducing new, simpler indices is proposed. The harmonica index and LASSO diagram have received positive feedback. Data transparency and raw data access are crucial, along with clear descriptions of calculation methods and visualization limitations. Presenting pre-analysis results can aid understanding. Concerns about sound source predictions due to a lack of standardization are also discussed. Urban noise observatories play a crucial role in understanding and mitigating the impact of noise pollution on communities. Two primary forms of noise representation are essential: noise maps and in-depth visualizations of measurement data. However, these representations must be enhanced by incorporating information about sound sources to provide valuable insights for various stakeholders, including the general public, industrial stakeholders, and urban planners. 3 distinct applications emerged from this investigation: addressing noise complaints, exploring soundscape dynamics, and guiding urban planners in their decision-making processes. Each application requires careful consideration of the choice of noise indices to prevent misinterpretation of data. For instance, the selection of noise indices can significantly influence the outcome of noise complaint investigations, while the use of inappropriate indices may lead to ineffective soundscape exploration. The authors emphasize the importance of data transparency and the potential benefits of integrating sound representations with other environmental data, such as air pollution. This integration can facilitate a more comprehensive understanding of the urban environment and inform evidence-based policy decisions. The research highlights the need for a multidisciplinary approach, incorporating insights from acoustics, urban planning, and environmental science. By acknowledging the complexities of urban noise pollution, this study contributes to the development of more effective noise management strategies, ultimately enhancing the quality of life for urban residents. The SENSE project is a collaborative initiative developing an innovative platform for environmental noise monitoring and management in urban areas. This platform integrates various tools and technologies to provide real-time data on noise levels, sources, and impacts, thereby informing decision-making processes for noise mitigation strategies. A key aspect of the project involves the development of new methods for analyzing and visualizing urban soundscapes, leveraging georeferenced data to create detailed maps of noise distribution. Other initiatives, such as Barcelona's Noise Monitoring Network and the RUMEUR network in the Paris region, are also focused on noise monitoring networks. These networks employ innovative approaches to measure environmental noise over extended periods, providing valuable insights into urban noise patterns and their effects on residents. Understanding sound source characteristics is crucial in assessing urban soundscapes, as proposed by Lavandier and Defrevel in their 2006 study. This understanding is essential for developing effective strategies to manage noise pollution in cities. By integrating data from multiple sources and utilizing advanced analytical techniques, these initiatives aim to create more accurate and comprehensive noise maps, ultimately supporting the development of targeted noise mitigation strategies. The SENSE project and similar initiatives have significant implications for urban planning and policymaking, as they provide critical insights into the complex relationships between noise levels, sources, and impacts. By leveraging these insights, cities can develop more effective noise management strategies, ultimately improving the quality of life for urban residents.